Hello and welcome. My name is Fiona, and I'll be representing my team, including Amani, Aditya, Emma, and Professors Mariana, Professor Randy, Professor Michael, and Professor Annie to present today. I'll be talking about our case study on a faculty initiative addressing gender disparity at a small STEM-focused university, namely Ontario Tech University. First, we're going to do a challenge deep dive. To give a brief background on why women students are less likely to major in CS programs, we found three factors through investigating related works. Firstly, we discovered gendered socialization, where female individuals are exposed to the external social bias that males are better at STEM fields than females by their family members and school teachers. Second of all, we read about technical anxieties, which is the internal self-perception that women do not feel confident in STEM. And thirdly, there is different career interest. Women individuals aspire to have career opportunities that involve social interaction and more nurturing. And so, although female students may perceive CS more positively than male students, and they may show respect for the field, there's an apparent hesitation towards women participating in more math, more science, and CS-related academic courses due to the stereotypes toward the CS field that there is less social interaction and that it does not relate to their interests. Let's dive into the Ontario Tech University where we carried out our case study. Ontario Tech University is located in Oshawa, outside of Toronto, one of the AI technology centers of the world. Canada's open door immigration policy has made Toronto one of the most multicultural cities in the world, drawing leading AI companies and researchers. This modern 20-year-old technology research institute is one of the #1 undergrad research university in Canada, with priorities in tech with a conscience and learning reimagined, with a diverse and cultural community of students. The computer science program boasts specialized research courses with technical labs and highly motivated trainees. Let's contextualize the problem of gender disparity at OTU. In recent years, the field of computer science has witnessed significant growth worldwide, yet this expansion remains marked by a gender gap at both the institution level and the industry level. At our Canadian institution, the CS program is the fastest growing in the Faculty of Science, and yet EDI initiatives are still at their early stage. In terms of our contribution, our case study delves into the level of gender imbalance within our CS program, revealing barriers in diagnosing gender imbalance and implementing gender equity initiatives at other small institutions. Here, we discuss the gender imbalance initiatives that were taken in other institutions compared to ours. The first initiative was led by Borsari and Valeria in 2018. They introduced learning activities targeting first-year CS students with little coding background and an outreach program for high school female students. As a result, women students admitted to the software development program increased from 11% in 2016 to 22% in 2017. Another activity was introduced by Zimmerman et al. In 2019. They led the BRAID program, which stands for Building, Recruiting, and Inclusion for Diversity. They interviewed 15 department chairs across the United States, asking them how the BRAID program went in their institutions. Many department chairs felt that the program effectively recruited diverse students after 2 years. In contrast, our framework consists of two major steps that could be followed by small new institutions. The first step is to explore the specific circumstances regarding progress in terms of gender imbalance. The second step is to form future initiatives to minister the lack of representation of minorities, including women, in CS programs. Our case study examined the gender gap at small, newly established institutions and implemented strategies to address gender imbalance challenges. Our work followed the Great Idea Framework, which is used to promote inclusion, diversity, equity, and anti-racism. Great, the G in GREAT stands for goal. Our goal is to identify the level of gender imbalance at our institution and outline appropriate initiatives that can improve the imbalance. The R stands for research, which is research on what has been effective in the past in improving the gender imbalance. E stands for engagement. It is engagement with faculty in implementing gender equity initiatives. The A in GREAT stands for action, which is how we execute the outlined initiatives. And finally, the T stands for tracking, which refers to monitoring ongoing developments and ensuring continuous improvements. Next, let's delve into the implementation of our initiatives. Firstly, we carried out an exploratory data analysis on the representation of women at our institution. Then, we collected external best practices to address these issues. Following that, we carried out an internal assessment of the gender gap problem at our university, and finally, we disseminated and mobilized our plan. Here you can see a flowchart detailing the exploratory analysis on gender imbalance, our list of initiatives, our exchange of ideas and research and surveying to research best practices, and finally, our finalized and updated list of initiatives. I will go into the results of our implementation. We found a lack of female role models, a leaky pipeline with female students, and a need for more inclusive classrooms and safe spaces. I'll go into these points a little bit later on. First of all, as a result of our exploratory data analysis, we found that the computer science program at our university is lacking in the percentage of women who are participating in the program. As you can see from this diagram here, the red line is the overall trend of percentage of women who are enrolled in other disciplines, in other majors, and the blue line represents the percentage of women enrolled in the computer science program. You can see that there is a vast difference. In other disciplines, it's mostly women are enrolled at about 45, almost half of the student body, whereas in computer science, this number stays below 15%. And the x-axis is the academic year from 2006 to 2022. Next, by attending the conference 60 in 2024, we learned more about how we can update our initiative to make sure it is more inclusive. Firstly, we learned that women of color and those who identify as LGBTQ often benefit from a space that intentionally supports them and a classroom that encourages inclusivity through storytelling and personal narrative. We also attended panels with transferable knowledge that could help mitigate those issues, such as panels that identified the need for inclusion considerations for students with disabilities, with mental health and medical health conditions. Based on what we learned, we intend to emphasize the need for instructors to be sensitive to the needs of students with these conditions by introducing more accessible teaching materials at our institution. In our disseminated survey, participants highlighted that since enrollment averages at their university tend to be high, enrollment demographics are skewed towards high-achieving high school students, which is itself often a very skewed sample group. This leads to a very homogeneous first-year class at their university. Some other participants have noted that there's a lack of visible support and allies for marginalized groups. Another thing that was noted by participants is the leaky pipeline for female students, in the sense that even if women students enroll and get accepted into CS programs, they often choose or are influenced to leave the program. Participants noted that this may be due to a lack of role models. I will now go into the proposed strategies to combat gender disparity. So there are student-centered and there are faculty-centered strategies. Student-centered strategies include more affinity groups, more diverse role models, diverse alumni panel for students, women in CS conference that students can attend, whereas faculty-centered include more female faculties and TAs and inclusivity lessons for faculty members. In general, we note that student-centered strategies are easier to implement than faculty-centered ones because the faculty-centered ones require substantial funding and logistics from the CS department. They would require, a lot of resources and therefore are higher difficulty. The lessons that we learned from our case study is that firstly, small institutions usually face unique benefits and challenges, and that secondly, we require systematic changes to address gender disparity, to retain more women in CS, and we need more faculty initiatives to engage in EDI. Going into a little bit more detail. Firstly, we learned that addressing gender disparity at small institutions has unique benefits and challenges for small institutions. Firstly, it is easier to make sweeping program level changes to address gender disparity at small institutions. It is possible to create multiple first-year pathways, which has been done for the first time this semester at our institution. And at small institutions, there is a lack of bureaucracy. However, there's also limited outreach and resources. We found it difficult to disseminate the knowledge of EDI issues at our institution, and there were a lack of responses for our survey. We only got 4 responses for our survey. We also found that institution size and resource scarcity do not have to inhibit meaningful progress because we conducted our case study with very minimal resources. Secondly, the lesson in terms of needing to retain women in CS. The problem is that there's a lack of representation of women in computer science, which leads to a lack of visibility. So women are disincentivized to enter computer science. And then upon entering computer science, women are given jobs that undersell their talent as a research paper has found. And this means that not only are they disincentivized to enter CS, they are also disincentivized to stay in CS. The solution for this is to change the system to reward women students for their talents and their diverse experiences. This would this to encourage women to stay in computer science, they would need to get fair work. And to encourage women to enter computer science, they need to see that their talents will be rewarded. The second part of this second lesson is on faculty initiatives to engage in EDI. First of all, faculty members generally acknowledge the existence of a gender gap. However, this often does not translate into engaging in EDI initiatives themselves, and this is potentially why we could not engage more CS faculty with our case study. This lesson is underscored by the fact that EDI does not play a significant role in promotion and tenure review, and there's a solution to this, which is making EDI an important indicator of a faculty member's success. Next, we'll discuss the limitations of our case study. There's a small sample size for our survey, which ties into a lack of reach. We had difficulty in encouraging faculty to participate and engage with our approach to addressing gender disparity. And thirdly, we are a STEM-focused university with no arts program. This might be a contributing factor to the lack of women in CS at our university. And universities with liberal arts may require different interventions in terms of women students' participation. That is the end of the presentation, and thank you for listening. Please ask any questions.